Hello. In this session, we will discuss about galvanic cell. It is a device that is used to convert chemical energy into electrical energy using indirect redox reaction. It consists of two components, an anode and a cathode. The anode half cell consists of a zinc rod dipped in 1 molar zinc sulfate solution, and the cathode half rod consists of a copper rod in 1 molar copper sulfate solution. Zinc and copper rod are connected by a metal wire, and the two solutions are connected using a salt bridge. The salt bridge contains concentrated solution of KCl in agar-agar gel. The symbolic representation of a galvanic cell is also called as a cell diagram. It is represented below. As can be seen, anode is written on the left hand side and cathode is written on the right hand side. The phase boundary are represented by a single line and salt bridge by a double line or a parallel lines. Oxidation or loss of electron takes place at the anode, whereas reduction or gain of electron takes place at the cathode. A galvanic cell can be set up by coupling together any two suitable half cells. One we have already seen. Two other examples are also given here. The first one contains magnesium taken as an anode, whereas zinc is the cathode, and in the second case hydrogen is the anode and copper is the cathode. What exactly is a salt bridge? Salt bridge is a U-shaped tube containing a concentrated solution of an inert electrolyte. The electrolyte may be either KCl, KNO3, ammonium nitrate or any other such electrolyte in an agar-agar gel. The important point to be noticed is that the mobility of both the cation and anion should be almost same and they should not react with the species in the cell. The functions of a salt bridge are: it helps us in completing the electrical circuit in a galvanic cell, prevents accumulation of charges in the electrolyte solution of the cell by allowing free migration of ions through it, maintains electrical neutrality by providing its own ion, and it also prevents mechanical mixing of the two electrolyte solution in the cell. Thus, it helps to avoid liquid junction. It is represented by two vertical lines between anode and cathode. Daniell cell is an electrochemical cell originally developed by John Frederick Daniell, an English chemist. It consists of an anode wherein a zinc rod is dipped in zinc sulfate solution and a cathode where a copper rod is dipped in copper sulfate solution. The two rods are connected by a metal wire and the two solutions are separated by a porous diaphragm. Electrochemical cells can be of two types, reversible and irreversible cell. As the name indicates, in the case of a reversible cell, the driving force is infinitesimally greater than the opposing force, and hence it can be reversed by applying a force infinitesimally greater than the one acting on it. For example, if we connect an external source of EMF exactly equal to that of the cell, no flow of current occurs. If the external source of EMF is slightly smaller than that of the cell, a small flow of current from the cell occurs. On the other hand, if the external EMF source is slightly or infinitesimally greater, then a small flow of current occurs to the cell and cell reaction is exactly reversed. The Daniell cell that we discussed previously is an example of a reversible cell. An irreversible cell is a cell that does not satisfy the above conditions. Electrode constituting a reversible cell are themselves reversible. Reversible electrodes are of three types: electrode reversible with respect to cation, electrode reversible with respect to anion, and oxidation reduction electrodes. Let us now look at the case of electrodes reversible with respect to a cation. This consists of a metal rod dipped in a solution containing its own ion. They are reversible with respect to the metal ion. That means that the metal atom in the rod may lose electron and come into the solution as metal ion, or the metal ion may absorb electron and deposit onto the metal. Examples are zinc rod dipped in a solution containing Zn2 plus ion, copper rod dipped in a solution containing copper 2 plus ions, or again silver dipped in a solution containing Ag plus ion, or again hydrogen gas bubbled over platinum in a solution containing H plus ion. The second category is that of electrode reversible with respect to an anion. The first example is that of a gas electrode or a chlorine electrode, wherein chlorine gas is bubbled over a platinum electrode containing chloride ion in solution. Another example is a metal insoluble metal salt electrode, wherein a metal like silver is in contact with a sparingly soluble salt silver chloride and the solution contains chloride ion. The more widely known calomel electrode is also an example for this type. In all the above examples, electrodes are reversible with respect to the chloride ion. The next is an oxidation reduction electrode or a redox electrode. It consists of a relatively inert metal like platinum immersed in a solution containing ions in two different oxidation states. First example is that of a ferrous ferric electrode, wherein an inert metal like platinum is dipped in a solution containing both ferrous and ferric ion. The ferric ions accept one electron and get converted to ferrous ion and vice versa. Another example is that of stannous tannic electrode, wherein platinum rod is again dipped in a solution containing Sn2 plus and Sn4 plus ion. Again, the conversion from Sn4 plus to Sn2 plus and back is reversible. We come to the end of this session. Thank you.